Hello guys, so today I am showing you the DIY grass cutter I made at home. So the parts required for this, first of all, a lithium polymer battery, preferably similar to this or larger, with an XT60 connector and the female port to receive the power. And inside, as you can see, here there's an Arduino Nano with the program and a variable resistor over here. So all of this composes the control circuitry, and I have placed it in this box. So then you would need a compartment where you can route the wire and reach the motor. So here I have used a 1400 kV BLDC motor and this 30 amp ESC. So I'm routing the cables through this hole to the control circuit, and so we can attach the cutting blade to this end. The BLDC motor is a type of DC motor which uses alternating signals in the 3 poles, and as it seems, it looks like a positive wire, a negative wire and a signal wire, but it's actually the 3 phases of the BLDC motor. And so the ESC controls the 3 phases and allows the motor to move in a really fast manner. We can use these 2 adapters to place a blade here. So the blade I am using is one that I made myself. It is a 5-inch wood cutting blade with some foam board on either side to make it the right thickness to attach it. So this is for chopping the harder grasses or weeds which may arise, or tree branches, or whatever. And so we will be using 3 zip ties in these attachment holes like this. To handle the smaller grasses. As you can see, the blade is complete, and so these zip ties can mostly cut the grasses, but if the zip ties can't cut, the blade inside can. And so some of you may be wondering what the kV rating actually means. So the kV rating of a BLDC motor is the voltage divided by the RPM. So to find the speed of this motor, you can just multiply the kV rating by the voltage. So we are using an 11-volt battery. You can just multiply kV by voltage, and so 14,000 times 11, you will get around 154,000 RPM at the motor. So this motor in the best conditions will reach 154,000 RPM. So but then sadly this motor doesn't have a lot of torque, but because of the RPM it can spin the blade. It's pretty heavy, so if you spin it up really fast, it can make up for the lost torque. So let's attach And so there's a tapped screw hole here, and as you can see a similar hole is here, so we can just screw it in. And here you can see the end of the screw, so that's where we attach this, similar to how you will attach a nut to a bolt. You can tighten it up, but then it may not be as tight as it can be, and so you can take something like a plier and hold it while you spin the motor from the back. And so now it's really tight. So here I've kept a small box to keep the battery, and so we can just plug in the connector. The Nano's on. The motor has started its starting sequence, and now it's on. So we can test it out by turning the potentiometer. So as we know, the grass cutter works in theory, but let's see if it works in practice. So guys, as you saw, the grass cutter can be used for industrial applications like trimming bushes or cutting grass. But one thing to keep in mind is that for children who are making this sort of product, you need to have parental supervision, and I made it for demonstrative purposes with the correct equipments and protection. So if you are planning to try this, please do take the proper precautions. Thank you.